Hi, we are going to find the distance from the point x sub 0, y sub 0 to the line ax plus by plus c equals 0. I'm going to drop a vertical line from the point p sub 0. And let me call this point p sub 1. And the x coordinate will be x sub 0 because it is a vertical line. I want to find the y coordinate for p sub 1. So we start with the equation ax plus by plus c equals 0. And we're going to plug in x sub 0 for x plus by plus c equals 0. We're going to solve for y. So we had a times x sub 0 plus c equals to minus by, and y equals to a times x sub 0 plus c dy by minus b. I'm going to put it here. A times x sub 0 plus c dy by minus b. Okay? I want you to look at these two lines here. Ax plus by plus c equals 0, and ax plus by equals to 0. These two lines are parallel lines. They are parallel lines. They have the same slope, but different y-intercepts. This one is going to the origin. Let me make that line. So here we go. This is the line ax plus by equals 0. I'm going to rewrite this into vector form. We can write down as the vector AB dot the vector XY equals 0. So it is the vector XY, and it is the vector AB. And they're perpendicular to each other because the dot product equals 0, so they're perpendicular. But remember, these two lines are parallel. So let me call this the normal vector n. This vector AB will be perpendicular to this line as well because these two lines are parallel. So let me call this the normal vector n. If this is the angle theta, this one will be angle theta. All right? Now we're going to find out what is the distance d. Well, d is just, look at this white triangle here. The hypotenuse times the cosine of theta will give me d. So, and the hypotenuse is just the magnitude of the vector p1, p0. The magnitude of this vector from p1 to p0 times the cosine theta. And that is the same as what? P1, P0. I'm going to multiply up and down by the magnitude of the normal vector. I'm going to multiply up and down by the normal vector. I can do that because they are the same quantity. But this one is just the dot product of P1, P0 dot the normal vector divided by the magnitude of the normal vector. This is just the definition of the dot product. Well, what is P1, P sub 0? Well, we're going to use the endpoint to subtract the initial point. So we will have x sub 0 minus x sub 0 and y sub 0 minus the y component of this point. So we had y sub 0 plus minus negative b become positive. A sub 0, a times x sub 0 plus c divided by b. And dot the normal vector and divide by the magnitude. Well, that is the same as what? It is the same as 0. And simplify this. We will have a times x sub 0 plus b times y plus y sub 0 plus c divided by b. And dot to the normal vector. The normal vector is just ab. And divide by the magnitude. The magnitude is just, the magnitude of this vector will be just sum of the squares of the components, a squared plus b squared. All right, so d equals to 0 times a plus this quantity times b, which is a x sub 0 plus b times y sub 0 plus c divided by b, and multiply to b, and divide by square root a squared plus b squared. But we are finding the distance, so we take the absolute value of this constant, of this expression. So d equals to, that is just 1, and that is cancel. So we had a x sub 0 plus y times b times y sub 0 plus c divided by square root a squared plus b squared. Take the magnitude of it. And I think that's the end of it. And thank you for watching.